Hello everyone, welcome to the NN Classroom. Today, I'd like to share with you a past paper question from 2019, Time Zone 1 in May. Question number 14, relating to the topic 5, even for SL student, topic 5, energetics. Let's see. When equal masses of X and Y, first of all, the first information has come. Equal masses of X and Y absorb the same amount of energy. Their temperature rises by 5 degrees and 10 degrees Celsius respectively. Which of the following statements will be correct? So here comes an equation that should pop up in your mind in the very first position. That is this one. Q equals M times C times delta T. Simply says Q equals MC delta T, right? So for this example, they're going to say two important information. The mass is going to be equal, and also the amount of energy that they absorb is equal. So that means if we establish two equations, another M, again MC delta T, right? One side will be of mass X, one side will be of mass Y, and these two will be actually equal. Make sense? And the energy that they absorb or the energy that they take in, right, will then be also the same. And what does the energy stand for? That means the Q, right? So that means both parameters, Q and M, will be the same. But they say the temperature rise is going to be different, in which X rises for 5 degrees and Y rises for 10 degrees. So that means for this, if it is for the X equation, this will be 5 and this will be 10. And finally, asking for the statement. And obviously, the statement all regarding the specific heat capacity difference. That's true, because if all other parameters are given, the only parameters that is testing, which is the final number, so that is the theta, right? For this idea, actually this is going to be a simple maths concept, because as we can see, the Q and the M is now given to be constant, the same, right? So given that one side the delta T is double, so that means for the specific heat capacity case, the other side need to be double in order to compensate this doubling effect, right? Make sense? Or simply speaking, if all other numbers must be the same, or the left side is to be the same, and you have a number that is double, that means on the previous equation that these numbers should be doubling for the specific heat capacity for Y. So, or you can apply some numbers. If I'm given this to be 10, then you need to be 5 this time. So now you can see after the multiplication, both will then be the same number. Assuming the same mass, that all multiplied with the same value of the heat, the Q, that is also to be the same. So that's why for this case, the final judgment is that the specific heat capacity regarding X should be double than that of the specific heat capacity of Y. So that's why the best description for meeting my expectation, which is going to be A. The specific heat capacity of X, so this is CX, is going to be as twice as much as that of Y, right? So that's why the answer for this case is going to be A.